The Sandbox, scientists accessing necessary data based on experimentation, was implemented in the CAVE virtual reality theater. The CAVE is a projection-based virtual reality system where the user enters a 10-foot square room. The user can move around the cave reasonably unencumbered and can walk around or through virtual objects. Much of the data that is stored in scientific databases was collected through experimentation. Using virtual reality, we can allow an investigator to collect data from the scientific database in much the same way that the original data was collected. That is, by placing virtual instruments into a virtual reenactment of the original experiment. The Sandbox gives an investigator a virtual laboratory that can be configured for different experiments on different scientific databases by loading in different sets of instruments and environments. In this prototype, we are using a subset of NASA's FIFE climatological database. In the middle of the environment, you can see an elevated plain showing a 20-kilometer square patch of Kansas. A Landsat photograph is mapped onto the plain, showing the various features of the landscape. A calendar on the left wall allows the user to choose which days to run experiments. For example, we can choose to run experiments on the 12th, 13th, and 14th of the month. Time now begins passing in the environment. A virtual sun and moon begin to orbit the plane, showing the current time of day. The instrument palette shows the instruments that the user can place into the virtual environment. These virtual instruments perform the same function as the actual instruments used in the actual experiment. The user has a thermometer, windsock, and water beaker to measure numeric data, a satellite, airplane, and helicopter to visualize graphical data, and a notepad and camera to see metadata. Let's grab a thermometer. All of the sites where temperature data was collected are now highlighted on the plane. The user moves the thermometer over to a chosen site and places it there. The instrument immediately comes to life, showing the current temperature. The user can similarly place a beaker which fills with water as the rains come and go, and a windsock whose direction changes with the wind. The current readings are shown graphically by each instrument and numerically by the values shown above each instrument. The values over time are shown in a graph on the back wall. The user is also given auditory feedback, a drip sound when the water level in a beaker increases. A cicada gets louder or softer with the changing temperatures, and a whoosh sound announces the current strength of the wind. A user wanting to look at the plane in a different light can place the satellite over the plane. Bringing up the satellite's menu, the user can choose to see the landscape in any of the Landsat bands. If the user wants to look at some metadata, in this case photographs taken of the sites on the ground, the user can place a camera at one of the sites on the plane. The user is now simultaneously seeing numeric data visualized by the instruments, graphical data showing the features of the landscape, and metadata showing a site photograph. All of the values rotate to follow the user's movements in the virtual environment, so they are always visible. The user can alter the environment by bringing up a menu for the elevated plane. This allows the user to shrink or enlarge the plane, raise it or lower it, or turn on a set of grid lines, giving the user the ability to see the environment from different perspectives. The user can alter the settings on the instruments by bringing up a menu for each of them. The user can change the range of values displayed and how those values are displayed. The Sandbox user directly manipulates familiar measuring instruments and can use the feedback from these instruments to browse through the data in the database. The user can integrate numeric data, graphical data, and metadata from the database to see how they relate. The Sandbox allows the user to become an active participant in the experiment, placing instruments and taking measurements. It gives the user an environment to work in, rather than just a screen to look at.